All right, today we're going to look at function operations. Yesterday we looked at multiplying, adding functions. Today we're going to look at what's called the composition of functions. So another function operation uses the output from one function as the input for a second function. This operation is called composition of functions. And the notation, you have to be really, really careful because it has an open circle, an open dot, whereas multiplication is a closed dot. So just be careful that these are different. Okay, so it's like f circle g of x, which is also known as f parenthesis g parenthesis x. So the way that you read this is f of g of x. So what you're going to do is you're going to always start on the inside and find out what g of x is, then plug it into the f of x function. Okay, so you always want to start inside and work your way out. Now domain, if we remember, domain is the set of all x values and for most of our domains they were all real numbers or negative infinity to positive infinity, and that's because so far we've looked at linear, which go on forever and ever, and we've also seen quadratics that go on forever and ever, and even our cubics would go on forever and ever. So typically our domain is going to be negative infinity to positive infinity. All right, so for example 6, they ask us to find the composite of these functions, f of g of negative 5. So again, it's probably easier if you write it f of g of negative 5. So we're going to start by finding out what is g of negative 5. I'll just go off to the side for that. So g of negative 5 means we're taking negative 5 and we're plugging it into the g of x function, okay, which is x squared. So that would be negative 5 squared, which will get me positive 25. So you take the 25 and you plug it back in, getting rid of this whole thing to get f of 25. And then once you have that simplified, all we then have to do is plug 25 into the f of x function. The f of x function is x minus 2, so this would be 25 minus 2. And so we get that our final answer for f of g of negative 5 is 23. You don't have to rewrite this answer, you can just get your answer of 23. Okay, the next one, we have the same question but in reverse. So this is g of f of negative 5. This time we'll start inside and find out what f of negative 5 is. So the f function was x minus 2. So negative 5 minus 2 gets me negative 7. So we take that negative 7, plug it back in to make it g of negative 7. Now we go to our g of x function, which is x squared, and we'll substitute in negative 7 for x. Negative 7 squared is a positive 49. Okay, down here we have the same type of problems, different functions though. So again, we're going to start on the inside with g of 3. So we're going to plug 3 in for our g of x function, which will get me 9, so this will be f of 9. We're now going to plug 9 in to the f of x function, which is 2x minus 3. 18 minus 3 will get me 15. See if you guys can try the next one on your own and pause the video. Okay, you can check and see if you got that one right. We should be getting 9 as an answer. Finding f of 3 first, which is 2 times 3 minus 3, which is 3. And then g of 3, which is 3 squared, which gets us 9. Now down below, for number 8, you'll just notice that we have an exponential function. We have something being raised to the x power, which makes it just a little bit different, but really the same concept still. still starting at the inside of your composition of functions, g of 4. So we're going to plug 4 in for the g of x function. G of 4 would equal 7 minus 4, which is 3. So now we have, instead of f of g of 4, we have f of 3. And now we just need to plug in 3 for x in the f of x function. So 2 to the third power, which will get me 8. Next one, start on the inside, f of 4. Find out what f of 4 is. Well, that's 2 to the 4th power. And 2 to the 4th power will, of course, get us 16. So we have g of 16. We now plug into the g of x function, 7 minus x, and we will get negative 9. Go ahead and pause the video and try the last one. I will reveal the answer in just a moment. We should be getting 512 if done correctly. G of negative 2 is 9, and then f of 9, 2 to the 9th power, is 512. Now what we're going to do on the back of the note sheet is we're going to take away the numbers, the 4 or the negative 2, and we'll just be seeing the composition of functions algebraically with just variables. So you can use algebraic expressions as well as numbers as inputs into functions. To find a rule for f of g of x, substitute the rule for g into f. Okay? Still going to do just what we did before. We're going to start inside of our process. Inside of the parentheses, we have g of x. So we're going to take the function for g of x, and we're going to substitute it in. Okay? So we'll get f of 3x plus 1. Just substituting in what g of x is. Now, that means we have to plug this whole quantity in for x in the f of x function rule. So I'm just going to rewrite what f of x is. F of x is x squared minus 1. So we're actually taking this and substituting it in for x. Normally it's f of 2. We plug in 2. Okay, just as not a number, it's an algebraic expression. Now we will use parentheses. 3x plus 1 quantity squared minus 1. And then don't forget, when you have a binomial squared, you do have to expand it and FOIL. And I'm going to come up over here. So whenever we FOIL this, we will get 9x squared. Plus 3x will be plus 6x plus 1. And then we also have this minus 1 outside. So the plus 1, the minus 1 will simplify to be 0. So my final answer is 9x squared plus 6x. They also want us to state the domain of this function. So thinking about it, are there any restrictions for values that wouldn't exist? No. This would be a quadratic, which would look something like this. So we can say that the domain, you can either say is all real numbers. You could also use the symbol for all real numbers, which is r. Or you can do interval notation, which is negative infinity to positive infinity. I don't care which one you use. They are all acceptable. All right, now we're going to do the opposite. We're going to take g of f of x. So again, starting inside with our f of x, we're going to take the function for f of x and substitute it in. So we'll have g of x squared minus 1. Now we're plugging this whole quantity in for x in the g of x function, which is 3x plus 1. So we're taking this whole thing and plugging it in for x. You will want to use parentheses since 3 is getting multiplied by both of those things. Distribute and combine our like terms. So see how these are different? So the order in which you take the composition of functions will yield you a different result. Now the domain for this one, it's still going to be a quadratic. So the domain is still going to be all real numbers, or negative infinity to positive infinity. Okay, now 10 is going to get a little bit different in terms of especially the domain because we see square roots. Okay, so you have to remember graphically, when we take the square root, you can't have a negative number underneath here. Okay, so anytime you see a square root for the domain, you're going to have to say that the radicand, which is the number under the radical or variable, has to be greater than or equal to 0. Okay, because otherwise we're going to get imaginary numbers, which aren't actually existing in our domain. Okay, kind of getting ahead of myself. Let's go back to our functions and we'll classify the domain at the end. Start on the inside, g of x. So take the g of x function, substitute it in. F of the square root of x plus 2. Now the function for f of x is 3x minus 4. So we're going to take and substitute in this whole quantity for x. Again, make sure you use parentheses since this is a binomial. Distribute. We'll get 3 root x plus 6 minus 4. Combine our like terms there, we'll get 3 root x plus 2. Now, normally, the domain would be all real numbers. However, this is not going to be the case. And if you want, I could graph this just to show you guys what this will look like. 3 times the square root of x, make sure you close your parenthesis, plus 2. We'll zoom 6 to get a picture. Okay, so it's almost like it's half of a parabola. You see this parabola, it would normally go this direction, but it's only half of it. And that's because of the square root. So if you don't want to have to graph it every time, and you just want to look at this, again, you're just going to tell me that the radicand has to be greater than or equal to 0. The radicand is whatever's under the square root. So all we have to do is say that x has to be greater than or equal to 0. This would be your domain. Now another way you can write it is you can do bracket 0, comma infinity, which means that it starts at 0 and it goes on forever and ever. Okay, let's make sure we pay attention for the next one, just for the domain really is going to be the tricky part here. So we'll start with our f of x, subbing it in. So f of x is our 3x minus 4, so we'll get g of 3x minus 4. This is going into my g of x function, which is square root of x plus 2. So this whole quantity is going in for x. This actually cannot be simplified any further. Okay, because this is a binomial being added or subtracted. So that's our final answer. Now for the domain, remember what I said up here. The domain is where the radicand has to be greater than or equal to 0. So we go and we look and see what is the radicand. The radicand is our 3x minus 4. So we're going to say 3x minus 4 has to be greater than or equal to 0 for our domain. We have restrictions on the domain. Then we have to solve for x. So we'll add 4 to both sides, divide by 3. So x has to be greater than or equal to 4/3. So this is one way you can write your domain, or you could do bracket 4/3 or 1 1/3, comma, infinity, which this is your lower bound. It actually can touch that because of the equal bar, and that's your upper bound, which is infinity. All right, go ahead and pause the video, and I will come back with the closure answers in just a moment. Give them a try. All right, coming back, number 1, we should have gotten pretty easily, plugging in 2x squared for f of x, and then plugging that into our g of x function, we should get 6x squared, which was letter F. Now for the second one, this one was a little bit tricky, just the ending step. So f of x was 2x minus 3. Now when you substitute this in, be careful, the only thing that's being raised to the second power is the x. So this is really negative, parenthesis, 2x minus 3 squared minus 1. The negative is just going to stay out front, and we're going to still expand this and FOIL it to get 4x squared minus 6x, which will be minus 12x, plus 9. And then we have that minus 1 at the end. We'll distribute the negative to get negative 4x squared plus 12x minus 9, and then we will subtract 1 from that, and we will get negative 10. The answer here should have been letter B. Okay. Homework is 7.6 day 2 homework, and you can see that on Google Classroom, of course.